Our next speaker this morning is Dr. Jason McCallum, research scientist, phytochemistry, AAFC Charlottetown. Dr. McCallum grew up on a large mixed horticultural farm in southern Ontario, where his family grew apples, sweet corn, sweet peas, greens, and yellow snap peas, cabbage, melons, squash, peppers, and tomatoes. Jason attended the University of Guelph and Waterloo with a focus on plant biochemistry. He has worked for AAFC since 2008 as a research scientist, researching the health-promoting compounds of food and plant defensive compounds. Since 2015, he has been involved in characterizing wild hops genetics resources for the Maritimes, with the goal of developing regionally adaptive cultivars. And he is here this morning to tell us how that work has progressed to this point.
Before I begin, I'd like to thank everyone who made it here this morning, and I'd like to thank Margaret and the other organizers for offering me the opportunity to speak to you today about something that's very near and dear to my heart, which is the Wild Hops Project. I'm going to try to keep things kind of simple today. Not everyone knows a lot about hops, so there's a little bit of information here, a snapshot of the state of the industry, globally and in Canada. I'll do a brief overview of the research activities we've been conducting in AFC at Charlottetown, finish up with the next steps that we hope to do, and if I'm on time, we can have some questions. So what are hops? They are a long-lived perennial crop. They can be productive for 20, 30 years or even more. They are clonally propagated. They are known by variety names. So just like you have a name for a wine grape or an apple, you have names for hops. They are a climbing plant. They get very tall. They sometimes get up to 30 feet in height. So there's quite an extensive trellis system required to produce hops. And the density is around 1,000 plants per acre. They're dioecious, which means there's individual plants that are males and there's individual plants that are females. Commercially, we only produce the female plants. We don't want seeds, so there's no males allowed. The flowers of the female plants, you can see here, they look a little bit like pine cones, but they're quite soft, and if you open them up, there's this sticky resinous substance inside that's full of aroma and embittering compounds, and that's what we actually grow the crop for. As opposed to food, we're growing it for chemicals. And as a chemist, that's why I got involved in hops. They're native to the Northern Hemisphere. There's multiple subspecies across 3 continents, and they've been used in brewing beer for over 1,000 years, primarily because of their preservative qualities. And depending on the style of beer, some beers might be 1 gram per liter, others could be 10, 15, or even more in some of these crazy IPAs that are popular today. This is a view inside a hop yard. The plants are grown in rows. There's quite an extensive support structure above them. It's generally airline grade quality aluminum and steel. Each spring the plants come up, send up shoots. You have to train them to climb up there. They climb like a canvas type rope, which is easy to cut during the harvest. This is a view above the hop yard. We had CBC came out and did a story with us last summer, and they took this footage with a drone. So if you look at these are telephone poles. So basically that's giving you the scale of what the crop looks like. It's a lot like a vineyard, but I call it a vineyard on steroids. Hops do best at the latitudes between 35 and 50 degrees. So that encompasses most of the arable land in Canada, including the Maritimes. The major production zones across the world are the United States in the Pacific Northwest, Germany, Czech Republic, Slovenia. China actually produces a lot of hops, but they don't really export. It's all for their own internal use. The last 2 decades, a comparable latitude in the Southern Hemisphere, they started growing hops quite successfully in Australia and New Zealand, and some of those hops are some of the most in-demand ones in the world today. A snapshot, the industry's worth between $1 and $2 billion a year. It's evenly split between the United States and Germany. It depends on how you make your statistics. Are we talking dollar values? Are we talking area planted? Are we talking yields harvested? Canada is an exceptionally small player in this at the moment, well less than 1%. So that's something that we want to change. These are some statistics that I pulled from an agri-food presentation that was put forward by our Pest Management Center and some statistics from the USDA. So you can see they're a little bit dated. I think it's 2020. Hops are growing throughout the country. The biggest players right now are Ontario and Quebec, but we do have some here in the Maritimes, especially in PEI. We have one of the largest growers in the country located here. The total Canadian acreage is around 250 hectares. It's worth about $3.5 million in farm gate value. You know, there is value-added opportunities after that with processing and selling and retail to home brewers and all that kind of stuff, but it's, you know, that's the farm gate value. So if we compare that to the United States, they're roughly 100 times bigger than us in the acreage, but they're making, you know, double and a half what our farmers are. And this has to do with varieties that are developed well for their climate that don't really grow so great here. They also have some fairly aggressive commercialization and vertically integrated industry. So we'll talk a little bit more about that later. So I say it's a bit of an industry in turmoil. You know, you could say the Canadian industry is in its infancy, but it really isn't. We've been growing hops for over 100 years here. It's just we're struggling to keep up. One of the reasons is that it's internationally traded commodity, and you're competing with everybody else. Hops can last for years if you preserve them properly. So, you know, when you're putting in an order, it could be for this year, last year, or the year before. The industry as a whole has suffered from some boom-bust cycles. You know, some acute shortage will cause a price spike. Growers will put in a whole bunch of acres. 3 years later, the price is in the toilet again. Everybody rips their hops out, and away we go. Over and over and over again, once or twice a decade. Across North America, the old-fashioned domestic lager beers, you know, things like Molson and Labatt's and Budweiser, that stuff is in terminal decline. Year after year after year, there's less and less of that product being consumed. Over the last 20 years, the craft beer industry was kind of a shot in the arm for hops because it was showing exponential growth, but at this point, the craft beer industry has plateaued. There's not a lot of aggressive growth in it anymore. In central Canada and here in the East Coast, we have new pathogens that are evolving or showing up. The worst of which that worries me is halo blight. It's showed up here 2 years ago, and we've really suffered from it. The industry in the United States is aggressively integrated. There's large corporations that control all the breeding and genetics. They license the people to grow it. The growers have to sell their product back to that parent company. They do all the processing and all the marketing, and they have their, you know, finger on the pulse of the magazines and the stuff, and the brewers that are reading these magazines want those products. So as a result, the newest and most in-demand hops that all the brewers are craving, we're not even allowed to grow here in Canada because the companies won't grant us licenses. And the things that are publicly available that do grow well here, they're not that well suited to our climate, and we're being outcompeted just on a yield basis. But it's not all doom and gloom. You know, this is a snapshot from this week. This is the area of the United States where they grow most of the hops, kind of centered around Yakima, and they're chronically dry. It's hot, dry mountain valleys. Doesn't snow as much as it used to. It's hard to get water to irrigate a crop. Hops are very water intensive. So, you know, their misfortune maybe give us a little opening in the door to exporting our crop to the United States. Same thing is happening in Europe. They grow land races that are centuries old, and they're starting to see a decline in the amount of biomass that they're harvesting, but they're also seeing a major decline in the quality of the product that they're producing. So one of the things that you grow hops for is a compound called alpha acids, and these lines that are centuries old, they just don't produce alpha acids like they used to under the new climate conditions. So there is some opportunities for us in Canada. You know, I threw these numbers together. This is growing degree days above 10 for, you know, the hops growing season, April through September. And the 30-year average is about 840 for Charlottetown, which is our Harrington research farm. So over the last 10 years, we've been well above that, 9 out of 10 times. So this will help with yields. This will help with cultivar selection and development. So, you know, as the climate changes, we do have some opportunities for advancement. So we've been doing hops research here in Prince Edward Island for 13, 14 years now. It was originally started by my colleague Aaron Mills. He's our agronomist and alternative crop specialist. He's spoken at this conference lots of times. You probably all know him. And over the years, we've kind of ping-ponged back and forth as leaders on these projects. Aaron was first interested in growing hops as an alternative crop. I'm the chemist, so he introduced me to the thing, and I got interested and kind of obsessed with it, and we've gone back and forth over the years. So Aaron's first project, it was a variety evaluation. What public varieties grow well here? How do you grow them? Let's make some recommendations to growers and figure out how to do it here. The real take-home message here was don't try growing them organically. Our climate, it just doesn't work. The European varieties, you can grow them, but they're not going to be too happy. They're quite sickly, take a lot of babysitting. And the USDA varieties will grow here, but we're not really competitive with what they're doing in the United States. The second phase of the project is where we started looking at wild hops. And really, it came about from a Friday afternoon conversation between me and Aaron. We both do outdoors things, hunting, fishing, etc., and we find wild hops growing out in the woods. And it's, if we're struggling to grow American varieties of hops in Prince Edward Island, but we already have wild hops here, maybe we can turn those things into varieties for ourselves. And because these things have been genetically isolated for so long, maybe they have different chemical traits or other quality traits, maybe they have improved disease resistance, and at a bare minimum, these materials are going to be useful for breeding programs. So in our region, we really have two different types of hops that grow here. In yellow is a native species that they call lupuloides, and it's been here for millions and millions of years, and it's the native crop. In green over here, we have the European hops that have been introduced by colonists. 300 and 400 years ago, they started bringing hops over with them to brew beer. Some of these plants have escaped cultivation. They've gone feral. They still have lived without human intervention. They have different characters or qualities. The wild hops the native wild hops tend to have higher levels of alpha acids, which is the bittering component for beer. They're a little bit lower on the essential oils, and the essential oils that they do make have some unusual flavors associated with them. 300 years ago, the European colonists didn't really like the flavors very much, but if you go to a craft brewery today, this is the kind of stuff that people really like in their IPAs. Conversely, the European hops, they have a lower alpha acid or bittering potential, and they have more flowery type characteristics to their aroma profiles. But because these two species or subspecies, I'm not going to get into that debate, believe me, it's a real debate. Because they're present in the same region, they can pollinate. The hops pollen travels more than 10 kilometers, so there's been 300 or 400 years of kind of natural breeding and natural selection going on in our area. So any given plant that you find growing someplace, you don't know what its origins were. So that's kind of where we got into the science of just characterizing what was there. When we first started, we had some old guidebooks and we'd found a few specimens ourselves, but we really wanted to have as large a collection as possible. So our public affairs branch put out the call to the public. It's kind of citizen science. We were soliciting people, do you know where hops are? Please tell us. And we had hundreds and hundreds of emails and phone calls. We were really overwhelmed with it, and we were actually really touched with it because of how much people cared about this project. Here's some pictures from the field. So, some of the plants are quite conspicuous. Growing up dead trees, they basically need a lot of light, so anywhere there's a break in the canopy, you can find them. Sometimes they take advantage of farmers' fields, growing on the fences that are there already. They're usually found around water. They are very water-intensive crop, so if you go down near creeks and things, you're going to find them. Sometimes you can spot them driving down the highway at 80 or 100 kilometers an hour, growing up telephone poles. What really struck us was that these are very hardy, vigorous plants. They're not getting any supplemental irrigation. They're not getting any fertilizer. They're not getting any pesticides. Some of them are growing in the ditch. They're exposed to road salt. You can't kill them. So we thought to ourselves, this stuff is ideal material to develop varieties from. So that process, we would dig up a piece of the root system and bring it back to the lab. It's called a rhizome. It's a specialized part of the roots. We could put it in pots. You hit it with the right temperature and water regimes, and that you could force it to sprout from the root. You can take cuttings of those sprouts, clonally propagate things up, clean them through tissue culture so that there's not any fungal or bacterial pathogens associated with them. Clone them and propagate them in our greenhouse. Start planting them out in our hop yard. So these are the plants when they were about 2 years old. And overall, we hit at least 100 places around the Maritimes over the course of 2 summers. We collected from probably about 60 of them. We did in-field selection. If it looked runty and sickly, we just left it. If there was only one plant, we didn't want to damage the population, so we didn't dig it up. Further characterization, we've identified things that we say are wild lupuloides, which are in the purple, and ones that are feral lupulus that are on old farmsteads and things in red. So that was kind of phase 2 of the project, was just assembling that collection. Phase 3 was evaluating the material, further characterization, see how it does in a commercial production setting instead of how it does out in the wild. And this is all in anticipation of applying for plant breeders' rights, which is an intellectual property process to protect the material for distribution. So what we did over the course of that project was we looked at their chemical composition, year after year after year to make sure things were stable. We were trying our best to get some yield data. There was some problems, which I'll get to later. Evaluate them for their agronomic characteristics, which ones are early maturing, late maturing, the size of the cones, etc. We did some disease resistance trials, both with inoculating material in the greenhouses, but also if we maintain the material in a commercial setting using commercial spray regimes. If it's getting sick when we're doing that, it's not going to be a useful plant. And we did some DNA analysis on them to help identify our materials, like a DNA fingerprint you'd see on CSI, or to actually get some DNA evidence of their ancestry. So some of these challenges I alluded to, we had our Snowmageddon event in 2015. That was the first year of our project where we're supposed to go out and find materials in the field. Well, there was still snow laying around in June, and the plants were really stunted and delayed coming out of the ground. 2019, we had Hurricane Dorian, which flattened our hop yard. It literally sheared the poles off, and the thing was falling over. We couldn't get it fixed because we had a little pandemic, and nobody could come and do work. 2022, after the thing had been replaced and fixed, we had Hurricane Fiona, and in anticipation that it might cause damage to the hop yard, we harvested the crop a bit early, so our numbers are a little bit off. It would have been better to let them mature for another 2 weeks. And then the last 2 years, we've had halo blight, which is a pretty devastating disease. The hops look great on Friday, and come Monday, they're all brown, and when you pick them and put them through the machine, they just shatter and there's nothing in the bucket. So in summary, as the kind of phase 2 of the project, we visited 100 sites. We sampled, did some chemical testing, we replicated, propagated, ended up with about 30 in the ground at any given time in replicated blocks. As we started doing some selections, we whittled that down to about 20 that we think, were worth maintaining. And right now, we're in the process of trying to release these as commercial varieties. We've had some science papers along the way. I'm not going to show any science data. It's just to say we had 4 publications. There's a 5th one on the way. Done a lot of media, a lot of industry meetings, craft beer meetings, that kind of thing too. So the word is out that we have this stuff, and it's definitely going to be an uptake by interested parties. So this is one of the ones that is our darlings that we think is going to make the list. We call it Aroostook because we got it from the city of Aroostook. Gentleman donated it to us. His friend had given it to him. It had been collected somewhere in southern New Brunswick. So even though it comes from Aroostook, it wasn't there originally. It looks like it's more of a European type in terms of what it smells like and the levels of the chemical compounds in it. It's a pretty good yielder, and the cones are very large. They're bigger than your thumb, which is kind of ideal for picking. And what we've noticed is that it is seemingly resistant or completely immune to halo blight. So the last 2 years when we've had problems, this is the only one that didn't get sick. And it's replicated plots, so we're pretty confident. The aroma is pretty good. It's got some citrusy characteristics and things. It's pleasant. A second one that we're interested in, where it's called Applehack, because that's where we collected it over in New Brunswick. It's a bit of a strange one. It has yellow leaves because it has some kind of chlorophyll mutation, and it's not nutrient deficiencies or anything like that. So we think it was probably grown as an ornamental originally. It has pretty high alpha acid levels for what's possible in our climate. The yield isn't that great, but the alphas are high, and it has this unusual phenotype. So we thought, let's pursue protecting this one. It has a little bit more of a muted aroma, but there's some zesty and spicy components to it. Third one is called Tantramar, and we basically, where you collected it, you were overlooking the Bay of Fundy, and you could see the Tantramar marshes. And this one was growing in the ditch along the guardrail, one of these ones that gets salt all over it, and it's pretty tough and robust. It is a good yielder. It has a strange chemical composition. Most hops have higher levels of alpha acids than beta acids, and this one's reversed. So there are some potential pharmaceutical uses for beta acids. People could contract grow to produce these compounds. They have some insecticidal type activities. So this one has an unusual phenotype, and it's worth pursuing. It has some of those sulfury type aromas though, the things you call cat pee and sulfur and things. It's a pretty strong one in that. But there are popular cultivars out there, one of which is called Citra, which every time I have a beer that's got Citra in it, you can taste the garlic and stuff. So. And this one we call Dig de Gouache. I probably slaughtered that. Aaron is much better at saying it. We really like this one because it's a super yielder. The alpha acids are kind of intermediate, but in years where we were struggling to collect 5 kilograms of material, we were filling garbage bags with this guy. So it's definitely a great candidate. So what we're in the process of doing now, most of the science is done. Now we're kind of handing things off for the regulatory stuff, which would include plant breeders' rights applications. It's a process that's administered through the CFIA. So we've collected data for it, but now it has to be audited and verified by the CFIA. After that, there'll be licensing opportunities, which will be run through our Office of Intellectual Property and Commercialization. There are some plans to collaborate with other hops professionals across the country and introduce some of our materials out there to see how they do in Ontario or Alberta. And then there's always the possibility of further work with breeders. So the plant breeders' rights, it's essentially a patent on a plant. People say, well, you didn't breed this, how can you patent it? Well, in the actual legislation, if you've spent a lot of time and effort and money characterizing things that are wild-derived, you can consider that selection activities, and it would qualify as a breeding effort. And what we're doing with this, it's not our intention to make scandalous amounts of money licensing things. We don't want these plants to be grabbed up by somebody, stacked on a shelf, and not used by the public. We want to make things available for the growers that are interested. So we've done all this work on yield and chemical composition and these types of things, but that's not the type of data you need in a plant breeders' rights application. It's more of a botany type application. There's 23 different physical traits you're measuring, and it's a bunch of things like what do the plants look like when they're growing up the trellis, what are the shapes and dimensions and colors of the cones, individual things on the petals on the cones, the ratios. So that's the type of work that we're leaving things off at. These are myself and Aaron's contact information. So if anyone's interested or wants further information, please feel free to contact both of us. I have to acknowledge the team that's been behind this work. I have a technician, Mark Neighbors, and I had a grad student, Spencer Gallant. Aaron's team has had Sylvia Wyand and Christian Gallant sitting right there. They've been working on this for years. So, all the pictures and slides and graphs I can make, they're the ones that are sweating out in the field. I helped them last year, but it wasn't pretty. So with that, I'll take any questions if anyone has any. Okay. There is a question? Oh.
So it looks like these plants are difficult to harvest. How do you take the cones off them?
Yep, so the ropes are anchored in the ground and they're tied to the steel cables at the top. So what we've been doing, and it's kind of standard practice, you use some kind of sickle blade on the bottom to cut the rope, and then you use a pole saw to cut at the top. I think on large scale commercial things, they'll have like a cherry picker and they drive down the row when people are chopping, but we have different occupational health and safety regulations than farmers do, so we use a pole saw. And then once you have this, 20-foot long thing, we have a harvester, you have a harvester picker where you can loop the bine on, and it gets pulled through a series of these like rotating fingers, and there's a little conveyor belt with gravity separation. All the leaves get blown out, and all the cones end up in the bucket. And that material is wet, so then it needs to be dried really rapidly, otherwise it starts to ferment and decompose. So you're putting them through forced air bed dryers, and that's just dried fluffy hops. Industrially, they take those and then they grind them up and they force them through an extrusion mill to form pellets. And then the pellets themselves are usually put into Mylar bags and vacuum sealed and flushed with nitrogen and things like that. So we're kind of Mickey Mouse in that respect. But yeah. And the hops harvesters themselves, we have a research grade one, which is good for our 1 acre hop yard. But if we were at 20 or 30 acres of production, we would have to have a much larger unit. So